Okay, so let's look at this first problem here. So here's the problem itself. And what we have to do is distribute both of the terms in this front set of parentheses with everything back here. So the first thing we're going to do is we're going to do z, the cube root of z times the cube root of z squared. So since those are both in a cube root, it's still going to stay in a cube root. And you're going to multiply the things that are inside. So what's inside is a z together with a z squared. 1 and 2 more z's gives you z to the third. So the first part is the cube root of z to the third. Next, we're going to do this front term to the middle thing. So that's going to be a -6 and then a z and a z is going to give you z squared. So inside the cube root sign, you've got a z squared. Last but not least, we're going to take this front term one more time, do the third root of z times 36, and that's this right here, 36 cube root z. So that's this term multiplied by that one, and that one. So there's 3 different results from multiplying that thing. Now we're going to move to the 6 that's in the back. We're going to distribute the 6 with all 3 of these terms. So 6 times a cube root of z squared is just 6 cube root z squared. 6 times -6 is -36, and then there's going to be just this lone cube root of z just there by itself. And last but not least, you're going to have 6 times 36, which is the number 216. Now, if we combine some like terms, something interesting is going to happen. Here's a -6 cube root z squared. Here is a +6 cube root z squared. They are exactly the same, except one's negative, one's positive. So if you add them up, they will cancel out. They're not there anymore. In addition, you've got positive +36 cube root z and a -36 cube root z. The same thing's going to happen. Those will cancel out and leave you with 0. When it comes to this, if you take the cube root of z cubed, a cube root cancels out a cube. So all that's left is just z, because that's the whole point of what cube roots do. They get rid of powers, basically. So you've got a z from this thing. You've got a 216 plus 216 back in the back. Everything in the middle canceled out. For the next problem, we've got the square root of 6x plus 4 and then a -5. We're taking that whole expression and we're squaring it. A good place to start, since it's squared, that means write it out 2 times. So here it is once, here it is again, and we're going to do FOIL with this guy. Now, if I do root 6x plus 4 times root 6x plus 4, if you do a root times a root of the exact same thing, they will cancel out the root. All that's left is going to just be what's inside, 6x plus 4. Because you're doing something times itself, you're squaring it, that cancels out the square root sign that is there. Next, we're going to do this square root times -5, so that's just going to be -5 times the square root, 6x plus 4. It's not really a whole lot you can do with that. For the inside, for FOIL, here's a -5, and we're multiplying that with a root 6x plus 4. So you've got another one of these, -5 root 6x plus 4. Then when we do the 2 terms that are last, here's a -5 times a -5, which is +25. You've got a 6x, we'll bring that on down. Here's a 4 and a 25. If you add those up, that's a grand total of 29. Here you've got a -5 and a -5, so you combine those and that gives you a -10 with a square root attached. The square root works just like a variable. If I have -5y minus 5y, you call that -10y. Well, here it's this big honking square root thing, but it's the same exact idea. For the third one, we've got 7a over the 5th root of 8, a to the 8th, b to the 12th. Now, the first thing I'm going to do is I want all this junk underneath in the square root, in the fifth root sign, to be something with power. So instead of calling this 8, I'm going to call that 2 to the third power. 8 happens to be the number 2 to the third power. Now, in order to get rid of this root, basically what I need is I need powers of the 2, the a, and the b. And the way a fifth root works is it's basically going to divide a power by 5. So what that means is I need to get up to the next multiple of 5 that I can get to. And the question is, how many additional 2's, how many additional a's, how many additional b's am I going to need to get up to the next power that's divisible by 5? So if this has 3, that means I'm going to need to do 2 as the power for this one. That'll give me a power of 5 altogether. So we're rationalizing the denominator here. We're multiplying a fifth root on top and on bottom. We're going to put all this junk inside here. So you're going to have a 2 cubed. You're going to have a 2 squared. If you put those together, you'll get a 2 to the 5th. If I have a to the 8th, to get up to the next number divisible by 5, that'll be 10, which means I need 2 additional a's. So I'm going to need a squared. So a to the 8 with a squared is a to the 10. Lastly, I've got b12. To get up to the next number that I can divide by 5, that's going to be 15. That means I need 3 more to get up to b to the 15. Now, if I do this crazy thing on the bottom, I have to do the exact same thing on the top. I have to be fair. I'm going to do 7a times all this junk over here. In the meantime, what I'm now going to do is work out the fifth root of all this stuff on the bottom. And I mentioned this earlier, but what doing a fifth root is going to mean is each power will divide by 5. 5 divided by 5 is 1, so it's just going to cancel out, leave you with 2 to the first, or just a plain old 2. A to the 10th. The 10 will divide by a 5, leave you with a 2. That's a squared. For b to the 15th, the 15 will divide by 5, give you b to the third. So I've got 7a over this crazy looking square root. Since it was 2 squared up here, I did go ahead and rewrite that as a 4. And since this is 2 squared, that's really the number 4. There's one last thing we can do, because what you might notice is that outside the root symbol, there is an a right there. There's an a squared right there. So we can cancel an a from top and on bottom. What that means is the a that was on top is now gone. We've still got this big crazy looking root here. And then underneath all this, what I'm now left with is a 2, an a, and a b to the third. So that's a good stopping point for the first part. And then in my next video, I'll do some more of the homework questions you sent me.